Hello and welcome everyone. Before I start this video, there is an information for you. I will be posting here solutions of CSIR NET previous year papers one by one, subject wise and year wise, and also some other questions for your practice, and many more physics related interesting stuff. So don't miss out the upcoming videos. Today I will discuss mathematical physics questions from December 2023 paper. So the first question is, the regular representation of two non-identity elements of the group of order 3 are given by. So it is a question of group theory. You just have to apply some of the group properties and it will be very easy. In a group of order 3, there are 3 elements. And if 2 elements are non-identity element, then the third element which is left, it has to be identity element. And for 3 cross 3 matrices, the identity element is 1 0 0, 0 1 0, 0 0 1. Now there is a group property that if you multiply two elements of a group, it will give us an element which belongs to the same group. And in our case, there are only 3 elements in the group. So this third element, it has to be identity element. So we just have to multiply the two elements which are given in the options, and we have to check whether the elements give us the identity element or not. So checking the first option, 0 1 0, 1 0 0, 0 0 1, 0 0 1, 0 1 0, 1 0 0. So it gives us 0 1 0, 0 0 1 and 1 0 0. So not identity, so this is not the answer. Checking the second option, 1 0 0, 0 0 1, 1. Okay. 0 1 0, 0 1 0, 1 0 0, 0 0 1. It gives us 0 1 0, 0 0 1 and 1 0 0. So it is also not identity element. So this is also not the answer. Checking the third option, 1 0 0, 0 1 0. 0 1 0, 0 0 1, 1 0 0. It will give us 1 0 0, 0 1 0 and 0 0 1. Is it the identity element? Yes, it is. So this is the correct answer. Given the data points using Lagrange's method of interpolation, the value of y at x is equals to 4 is closest to. This is a question from numerical techniques. There are many methods of interpolation like forward difference, backward difference, Lagrange's method. Here you have to use the formula for Lagrange's interpolation method. So for nth order, we have the formula f of x is equals to x minus x1. So these x in f of x are, so it is x naught, x1 and x2, and it is f of x naught and like that f of x1 and f of x2. So x minus x1, x minus x2 up to x minus xn upon x naught minus x1, x naught minus x2 up to x naught minus xn multiplied by f of x naught. plus x minus x naught, x minus x2 up to x minus xn upon x1 minus x naught, x1 minus x2 up to x1 minus xn multiplied by f of x1 plus x minus x naught, x minus x1 up to x minus xn minus 1 upon xn minus x naught, xn minus x1 up to xn minus xn minus 1. This is a huge formula, but once you remember the formula, you will start to plug in the values, and it is a very simple question. So for second order, here we have 3 data points. So order is second, n is equals to 2. The formula is f of x is x minus x1, x minus x2 upon x naught minus x1, x naught minus x2 multiplied by f of x naught plus x minus x naught, x minus x2 upon x1 minus x naught, x1 minus x2 multiplied by f of x1 plus x minus x naught, x minus x1 upon x2 minus x naught, x2 minus x1 multiplied by f of x2. Now just put in all the values from this table 135 and 428 and 92, and x is equals to 4 here. So 4 minus 3, 4 minus 5 upon 1 minus 3, 1 minus 5 into 4 plus 4 minus 3, 4 minus 5, 3 minus 1, 3 minus 5 into 28 plus 4 minus 1, 4 minus 3 upon 5 minus 4, 5 minus 3 and 92. Just calculate it and let me know what is your answer. The next question is the solution of the differential equation together with the boundary conditions is the given differential equation is y double prime plus y upon 4 is equals to x by 2. As we can see, the right hand side is not 0. So it is non-homogeneous equation. For non-homogeneous equations, the solution is a combination of complementary function plus particular integral. So first, solving for complementary function. The equation is t square plus 1 by 4 y is equals to 0. M square plus 1 by 4 is equals to 0. So the roots will be m is equals to plus minus iota by 2. Whenever the roots are of the form of alpha plus minus iota beta, then we know that solution takes the form of e raised to power alpha x into a cos beta x plus b sin beta x, where a and b are constants. Here alpha is 0 and beta is 1 by 2. So complementary solution will be a cos x by 2 plus b sin x by 2. Now we will solve for particular integral. y pi is equals to 1 upon t square plus 1 by 4 into x by 2. So 2 is here and there is 4, so it will be 2, 1 plus 4d square raised to power minus 1 and x. Now you can expand it using 1 plus x raised to power minus 1, where x is less than 1. So it will be 2, 1 minus 4d square x, and it will give 2x. Now the complete solution will be yci plus ypi cf is equals to a cos x by 2 plus b sin x by 2 plus 2x. Now we can apply the boundary conditions. Y0 and y at pi is 0. So y at x is equals to 0 is 0, which is a plus 0, which gives us a is equals to 0. And y at pi is equals to 0, 0 plus b plus 2 pi, which gives us b is equals to minus 2 pi. So the solution is y is equals to minus 2 pi sin x by 2 plus 2x. 2 bracket x minus pi sin x by 2. So the answer is this, but the options are in the form of Fourier series. So now we have to find Fourier series for this function. We can clearly see that this function is odd as it contains x and sine. These both are odd functions. So whenever the function is odd, in the Fourier series, the coefficients a0 and an are 0 and only bn coefficients are non-zero. The bn coefficients will be bn is equals to 2 upon pi, 0 to pi, 2x minus 2 pi, sin x by 2, sin nx dx. Now you just have to solve this integration and it will give you the answer. It is a long integration to solve, but easy. The answer will be 4th. The function f of z is equals to 1 upon z plus 1 z plus 3 is defined on the complex plane. The coefficient of z minus z0 squared term of the Lorentz series of f of z about z0 is equals to 1 is. See, in Lorentz series questions, generally the region in which we have to find the series, it is defined. But in this question, the region is not defined. So the approach will be that we will first find the singularities for this function, and with the help of those singularities, we will find the different regions. And in those regions, we will try to find the Lorentz series of f of z about z0 is equals to 1. So the given function is f of z is equals to 1 upon z plus 1 z plus 3. The singularities will be for which the function is not defined. These are z is equals to minus 1 and z is equals to minus 3. To write this function in a simpler form, we will use partial fraction method. Using partial fraction method, 1 upon z plus 1, z plus 3 is equals to a upon z plus 1 plus b upon z plus 3. 1 is equals to a z plus 3 plus b z plus 1. Now, if we put z is equals to minus 3, then this term will be 0 and b is equals to minus 1 by 2. Put z is equals to minus 1. So this term will be 0 and a is equals to 1 by 2. So now we can write the function as 1 by 2 z plus 1 minus 1 by 2 z plus 3. So now we have the singularities, we have the function in this simple form. Now we will see the different regions. So if we look it in the complex plane, somewhere here will be z naught is equals to 1 and this is minus 1, this is minus 3. So draw a circle around z naught is equals to 1 which passes through z is equals to minus 1. And drawing a circle about z naught is equals to 1 which passes through z is equals to minus 3, it will be something like this. So let's say this is region 1, this is region 2 and this is region 3. Naming these regions. So first region will be where z minus 1 is less than 2. So you can see the radius for this circle is 2, right? So 1 is here and 1 is here. And the center is z is equals to 1. So we can write z minus 1 mod less than 2. The second region is 2 less than mod z minus 1 less than 4. And the third region is z minus 1 less than 4. The circle for this bigger, so the radius for this bigger circle will be 4, right? So we can write mod z minus 1 less than 4. So for the first region, z minus 1 is less than 2. We can write z minus 1 is equals to t for our convenience. So it gives us mod t less than 2. And the function will be 1 upon 2 z plus 1 minus 1 upon 2 z plus 3. So we can write it as 1 upon 2 t plus 2 minus 1 upon 2 t plus 4 because z minus 1 is equals to t. So z is equals to t plus 1, right? So it will be 1 upon 2. Now see here, t is less than 2. So we will use the expansion of 1 plus x raised to power minus 1. So the calculations will be easy. So we will try to write this function in that form 1 plus x raised to power minus 1. Okay. So we can take 2 outside. So it will be 1 plus t by 2 minus 1 upon 4. 2. So I have taken 4 outside. 1 plus t by 4. Okay.
So it will be 1 upon 4, 1 plus t by 2 raised to power minus 1, minus 1 upon 8, 1 plus t by 4 raised to power minus 1. So now you can expand it using the expansion of 1 plus x raised to power minus 1, where x less than 1. So it is expanded as 1 minus x plus x square by 2. Sorry. Minus x cube, and like that. So 1 minus t by 2 plus t by 2 square minus 1 upon 8, 1 minus t by 4 plus t by 4 square, and like that. So in this question, it is asked of the coefficient of z minus z naught square term, which means t square, right? T square term. So take out the coefficients which involve t square. One by 4, and here there is one more 1 by 4, plus here we have minus 1 upon 8, and here we have 1 upon 16. So calculate it. It is 1 upon 16 minus 1 upon 128, and this gives us 7 upon 128. So the answer will be second, 7 upon 128. Let's see. I've only calculated it for the first region and I've got my answer. So I don't need to calculate for the second and the third regions, but they should have defined it in the question itself, because one can calculate for the second region first and then come to first region, and then it would have been a longer calculation. So I will advise you to avoid these kind of questions in the paper. Next question. The beta function is defined as bxy in this form, and then bx y plus 1 plus bx plus 1 y can be expressed as. The beta function is given as bxy is equals to 0 to 1 t x minus 1 minus t raised to power y minus 1 dt. So if we write b x y plus 1, then see, in this form we just have to replace y with y plus 1. So writing it 0 to 1 t x minus 1 and 1 minus t, replace here y plus 1. So it will be y. And if we write bx plus 1y, then we just have to replace x with x plus 1. So 0 to 1 t, it will be just x, and 1 minus t, y minus 1 dt. Now we have to add these. So b x y plus 1 plus b x plus 1 y will be 0 to t, t x minus 1, 1 minus t y dt, plus 0 to t, t raised to power x, 1 minus t raised to power y minus 1 dt. So we can take t raised to power x minus 1 and 1 minus t raised to power y minus 1 common. So limits 0 to t, t raised to power x minus 1 and 1 minus t raised to power y minus 1. So it is 1 minus t plus t dt. T and minus t will cancel out each other, and the form we have is t raised to power x minus 1 1 minus t raised to power y minus 1 dt. Now see here, t raised to power x minus 1 minus t raised to power y minus 1. What is this? This is bxy. It is beta function bxy. So the answer will be bxy. So in some questions, if you see some term like in this question like beta function, gamma function, and if you don't remember the form, do not be afraid. Just look at the question. They have given you the form, and this is a very easy question you can see. Let M be a 3 cross 3 real matrix such that e raised to power m theta is given like this, where theta is a real parameter, then matrix M is given by. In this question, we will use a matrix property which says determinant of e raised to power m is equals to e raised to power trace of m. Trace is the sum of the eigenvalues of matrix M. So determinant of e raised to power m will be cos theta minus 0 plus sin theta and sin theta. So it will be cos square theta plus sin square theta 1. So determinant of e raised to power m is 1. 1 is equals to e raised to power trace of m. So trace of matrix M will be 0 because e raised to power 0 will give you 1, right? So now look at the options. The matrix M should have trace 0. In option 1, the trace of the matrix is minus 1 plus 0. It gives you 0. So yes, it can be our answer. In option 2, the trace is 0. It can also be our answer. In this, the trace is minus 1. So it is not the answer. And in the fourth option, the trace is 1. So it is also not the answer. So 3 and 4 are eliminated. Now we have to check only for option 1 and option 2. Now the approach to solve this question will be that I will find the eigenvalues for this matrix and then I will find eigenvalues for matrix M. So for this matrix, eigenvalues will be found, and for matrix M, we will find eigenvalues. Then we have this property that if matrix M has eigenvalue lambda, then the matrix e raised to power m will have eigenvalue e raised to power lambda. So I can get the eigenvalues for e raised to power m using matrix M. Then I will compare the eigenvalues which I got from this original matrix and the eigenvalues which I got using matrix M. If they are same, then it will be the answer. First, I will find eigenvalues for the original matrix e raised to power m theta. So finding eigenvalues for this matrix, cos theta minus lambda, sin theta 0, minus sin theta, cos theta minus lambda, 0, 0, 0, 1 minus lambda, cos theta minus lambda, cos theta minus lambda, 1 minus lambda, plus sin theta, and 1 minus lambda. So it will be cos theta minus lambda whole square plus sin square theta and 1 minus lambda common in these both. So cos square theta plus lambda square minus 2 lambda cos theta plus sin square theta, 1 minus lambda. So this 1 minus lambda will give lambda is equals to 1. And cos square theta, sin square theta, it will be 1. 1 plus lambda square minus 2 lambda cos theta is equals to 0. So the eigenvalues will be plus 2 cos theta plus minus 3 square minus 4ac. So 4 cos square theta minus 4 upon 2 cos theta plus minus iota sin theta e raised to power plus minus iota theta. So eigenvalues for e raised to power m theta are 1, e raised to power iota theta and e raised to power minus iota theta. Now we will check option 1. Minus 1 minus lambda 0 0 0 1 minus lambda 0 0 0 0 minus lambda. So it gives us eigenvalues lambda minus 1, 1 and 0. So for eigenvalues for e raised to power m theta will be e raised to power minus theta, e raised to power theta and 1. But the eigenvalues we have just calculated, these are e raised to power iota theta and e raised to power minus iota theta. So it is not the answer. We are left with option 2. It has to be the answer, but we will check it. Option 2 is minus lambda 1 0 minus 1 minus lambda 0 0 0 minus lambda. Lambda square minus lambda is equals to 0 minus lambda lambda square plus 1 is equals to 0. So lambda will be 0 and plus minus iota from this equation. So eigenvalues for e raised to power m theta will be e raised to power 0, e raised to power iota and e raised to power minus iota theta. So these are the eigenvalues we were looking for. So this should be the matrix M. An infinite waveform Vt varies as shown in the figure below. The lowest harmonic that vanishes in the Fourier series of V of t is. So what is a Fourier series? It is an expansion of a periodic functions in terms of sines and cosines. So we can write f of x, any function f of x, as a naught plus summation an cos n pi x by l plus summation bn sin n pi x by l, where l is half interval p by 2. P is period. In this function, the period is, you can see this function repeats itself after a period t. The period for Vt is t. Now it is asking the lowest harmonic that vanishes. So the harmonics are, we define first harmonic for n is equals to 1. So for n is equals to 1, we will have two coefficients a1 and b1. For second harmonic, n is equals to 2 and we will have two coefficients a2 and b2. And like that for nth harmonic, we will have coefficients an and bn. So now we have to look for the lowest harmonic for which these coefficients an and bn both vanish. They will be 0. Now finding an coefficient, an is 2 by t the limits will be from 5t by 6 to t, because only in this region the function is non-zero, and in this region the function value takes 0. So v naught, the limits will be 5t by 6 to t. V naught cos 2n pi x by t dx. We can take v naught out as it is a constant, and the integration will be sine 2n pi x by t upon 2n pi by t, 5t by 6 to t, 2v naught upon t, t upon 2n pi, and 0 minus sine 5n pi by 3. Now look at this term. This term will be 0 if this angle becomes integral multiples of pi. So for that, n has to be 3, 6, 9, and like that. So A3, A6, A9, these terms will be 0. But you don't have to stop here. We also have to calculate for Bn, and then we will see for which value of n, An and Bn both become 0. Now finding Bn, Bn is 2 by t, limits are from 5t by 6 to t, v naught sine 2n pi x by t dx. So take v naught out, 2v naught by t, integration is minus cos 2n pi x by t, 5t by 6 to t. So it will be 2v naught upon 2n pi and minus 1 plus cos 5n pi by 3. Now look at this term. This term will be 0 if cos 5 pi 5n pi by 3 is equals to 1, and this can only happen when this angle will be equals to 2 pi, 4 pi, 6 pi, and like that. So n will be 6, 12. So b6, b12, these terms will be 0. We have to find the n for which an and bn both are 0. So here A3 is also 0, but we can see that for n is equals to 3, B3 coefficient is not 0. If you put n is equals to 3 in this term, then it will be minus 1 and minus 1 minus 1, it will give you minus 2. And B3 is non-zero. So the lowest harmonic is n is equals to, for n is equals to 6, because for that A6 and B6 both are 0. So your answer is 6. The branch line for the function f of z is, first understand what are the branch points, what is a branch line. So the branch points are the singular points of a multivalued function. A multivalued function is a function which gives you more than one value, more than one output for one input. So for example, there is a square root function under root z. If you put z is equals to 4, then it will give you y is equals to 2 and minus 2. And if there is a function x raised to power 1 by 3, it will give you 3 roots. So for one value of x, it is giving you 3 values. For one value of z, it is giving you 2 values. So this is a multi-valued function. Now coming back to the function which is given in the question, f of z is equals to under root z square minus 5z plus 6 and under root z square plus 2z plus 1. Now look carefully. Can you write it in the form z minus 2 and z minus 3? You can multiply and check. This gives you z square minus 5z plus 6. And this is whole square of z plus 1. So it is nothing but under root z minus 2, z minus 3 upon z plus 1. Now look at these functions. Under root z minus 2, under root z minus 3. Aren't these multi-valued functions? So the branch points will be z is equals to 2, z is equals to 3. Now you can say that for z is equals to 2 and z is equals to 3, f of z becomes 0 and it does not gives you a non-defined value. But what about the first derivative of f of z? If there is a square root function, then the first derivative is in the form of 1 upon under root of something. So if this value becomes 0, then 1 upon root 0, it is not defined. So that is how these are branch points, okay? What about z is equals to minus 1? Z is equals to minus 1, it is a singular point because there is no square root here. It is a singular point. Now branch line. A branch line is a line connecting the branch points on the complex plane. So we can locate the points on the complex plane. We have z is equals to 2, z is equals to 3, and there is z is equals to minus 1, but it is a singular point and not the branch point. So branch points are only z is equals to 3 and z is equals to 2. So now join these and be careful. Do not include z is equals to minus 1 because this is not a branch point, okay? So join these. This will be the branch line. So third option is correct. The question can confuse you by giving the option this. So it is joining minus 1 and 3. But you have to be careful that z is equals to minus 1. It is actually a singular point. Okay. Next question. In the measurement of a radioactive sample, the measured counts with and without the sample for equal time intervals are C is equals to 500, B is equals to 100. Respectively, the errors in the measurement of C and B are delta C is equals to 20 and delta B is equals to 10 respectively. The net error delta Y in the measured counts from the sample Y is equals to C minus B is closest to. Here Y is C minus B and it is asking for error delta Y. So whenever the error delta Y is asked, that means they are asking for the root mean square error, RMS error, or the uncertainty. So uncertainty for this Y is equals to C minus B. It is given as delta Y is equals to under root delta C square plus delta B square. Put in the values which are given in the question. 20 square plus 10 square, it will be under root 500, and I think 22 square is 484, so it will be closest to 22. So the answer is 22. So these are 10 questions from mathematical physics portion of December 2023 paper. If you have any doubts or any suggestions or you want any other topic to be discussed, you can comment below. Thank you.